This is my implementation of total order broadcast with raft consensus algorithm. The setup is we have five nodes here, 1 2 3 4 5, and each node runs in its own addresses, and we are going to perform we're going to perform how raft algorithm works on total order broadcasting. So first let me start all the five servers. So you could see all the five servers have started, and there's a node which got elected as a leader for a term, and then the leader starts sending heartbeat from the node to all other nodes. You can see that four sending node to all the addresses, and all the other addresses are receiving the heartbeat from the leader. So now let's write something into. Okay, so I have an endpoint client, and I'm gonna write the set is equal to x is equal to 2, some value into the leader. Let's see what happens. You can see that it got committed as well as it has a commit index. Correspondingly, you can see all the other nodes receive the applied comments as well. X is equal to 2. So now what we can do is we can just I've written another endpoint which is called inspect. You can just see what value is in that endpoint and so on. So now I'm gonna hit the endpoint at which endpoint of fourth node. You can see the state of the endpoint is leader, and then it has the current term, and then the commit index, last applied, and so on. You can also notice that there is a log entry called term, which term this data is been written, as well as the command which we have written, that is set x is equal to 2. State machine always has the latest state. Let's see if the value got replicated among the others. So now I'll curl some other endpoint, that is like 5 or something. You can see the state of the endpoint is follower, and it has successfully been replicated, that is it has the term and it has the state as well. So now what we can do is we'll think of a situation where the leader fails and how the system works, because this whole raft algorithm, a leader is a very important node, because that's how total order broadcasting works. And let's see what will happen when leader dies. So now fourth is the leader, and then I am like bringing it down. You can see that one became a leader and it starts sending to all other nodes, and you can see this error message as well because it couldn't reach a leader 4. The base of distributed systems is when somebody goes down, it should be fault tolerant. That's why even though we log this message and the whole system works even if a leader goes down. So a new election happened, and then a new leader is picked up. Let's see, when we try to hit the endpoint 4, you can see there's an error because the server is down, and I'm trying to hit the leader endpoint. You can see the state is now leader, and it has this term as well as the state. Now let me write back into this leader and see what happens. So now I'm going to write set x is equal to 3 on the leader node. You can see the leader has a commit command of x is equal to 3, and it has commit index. What happens is, after the replication of the values to the all other nodes, it just commits the value, and this happens only if it follows the quorum rule. Half of the nodes needs to have the value, only then the value gets committed. Now let's call the, now you can see it has the log entry of the first term, value set is x is equal to 2 at term 4, and then there is value x is equal to 3 at term 8, and then you can see the latest value has been added in the state machine. Now I'm just bringing back the node. So initially it is in a follower state, everybody is in a follower state, and then you can see this immediate replication happens, and then it received this x is equal to 3, and then it started receiving the heartbeat from the leader 1. Now when I try hitting the endpoint, you can see it just has all the value replicated, even though it went down and got back. All the other nodes sent the value to this, and the value got replicated.